Very quick and easy section, just calculator work, something called Newton's method. If you ever wonder in pre-cal last year when you find zeros of graphs, that's the x-intercepts, the roots of the equation, where it crosses the x-axis there. Have you ever wondered, like when you did that rational root theorem, that P over Q thing, where you found some possible zeros and then you did synthetic division and found some more zeros? I don't know if you ever wondered back then, like what happens if you couldn't find any possible rational zeros and you couldn't do that synthetic division method right there? Pretty much there's a calculus method for that. So whenever you think of a problem there where your pre-cal methods are limited, you know, a lot of times there's a calculus technique for that. So this is just a calculator technique to find zeros. So here's how it's going to work. You're essentially just going to make this table: x of n, f of x of n, f prime of x of n minus f of x of n over f prime of x of n. You're going to make a blank table here. And then we'll give you a starting point. We'll give you a function. You'll need to take its derivative. We typically give you a starting point, the x of n, to start off your chart here. And that is just a number that's close to a zero. It's essentially a guess at what the zero actually is, what the x-intercept actually is, where that graph crosses the x-axis. And then what you'll do is you're going to do a few iterations of this Newton's method, and you're going to find out a better approximation of that zero right there. So our final answer is going to be a very close zero and a better answer than what we started with right there. So it'll say a lot of times just do 2 or 3 iterations of Newton's method, or it'll say do Newton's method till it varies by, till you get a couple successive iterations that differ by less than 0.001, which just means they want the first 3 numbers after the decimal to be the same right there. So here's how it's going to work. You'll start off with a blank one of these charts, and then we'll give you that starting point, and then you're going to take that x of n, that 0.6, plug it into the original function, get a number right there, write that down. And then you'll take that same number, 0.6, plug it into the derivative in place for x. You'll get a number right there, write that down. And then the way I have this organized, you'll take 0.6 minus this number divided by this number. So you're going to go 0.6, that's your x of n, minus the negative 0.184 divided by the 2.08, and you'll get that number right there. Now, typically, I like to write at least 4 numbers after the decimal, so because if I'm comparing the first 3 after the decimal, I want to have a little bit more extra leeway right there. So what this 0.6885 number, so you'll fill in that this stuff won't even be there. I'm just trying to make the notes a little bit shorter here for you there, make the video a little bit shorter for you. When you started with that, this 0.6885 number is a better answer than the 0.6 number. This is a closer answer to the actual zero than that 0.6. And what you'll do, this is your new starting number now. This is your new x of n. So you'll come down here and you'll now write this as your new guess. And then you'll do Newton's method again with this new number. So you'll now take the 0.6885, plug it into the original function, get a number. Take the 0.6885, plug into the first derivative, get a number. And then you'll do this number minus this number divided by this number to get that. And that's a better approximation. I'll notice this goes 0.689 and this goes 0.682. So if I'm comparing those first 3 numbers, they're not the same yet, which means you got to do it at least one more time. So now you take that, that's your new guess, take that number, plug it to the original function, take that number, plug into the derivative. Now sometimes practice this. I think this actually is a homework problem there I just did. You can kind of practice on your own, make sure you're doing that correctly first. Sometimes your calculators will give you scientific notation like there. You'll see like the e's in there. It should be like times 10 to the negative 4th or something like that. You gotta make sure you write the decimal answer for that. And then do this minus that divided by that to get you that. Now, notice I got 0.682, 0.682. Even if this is a 4 for the last number, the first 3 numbers is what we're looking for, where those are the same. So that's when we can stop and you're gonna get 0.682. So that's Newton's method. It finds zeros. What we'll also give you is we'll give you another kind of problem. We'll say find the intersection points between 2 graphs. Newton's method doesn't do intersection points. Newton's method only finds zeros. But if you want intersection points, here's what you could do is take the 2 equations, set them equal to each other, and then you can minus that, get everything on one side, set it equal to 0. Now, once you have a function set it equal to 0, now we can apply Newton's method there. So you just call this like your f of x, take the derivative of that. So now you have your f, you have your derivative, and then we'll give you a starting point right there to try, and then you make your chart, and then you do it the same exact way there. So just practice the calculator work there. It should be a pretty quick and easy section for us there, as long as you just follow that chart and get those numbers right in the calculator.